as well as the IP for SSH? Because this will be on the same IP, right?
Yeah, I'm going to do that right now.
Oh, okay.
Yeah, let me show you how this works. So Blade is the same IP address, except for now it's port 2015 instead of 2011. Okay? So log into Blade the same way you did Razor, just change that number. That's step one. Once again, you'll all have accounts. I got to delete all the accounts from last year's stuff.
What does Blade mean in your Etsy host?
Sorry?
So in that alias, it says Blade inside that.
Oh yeah, it's the same IP as Razor.
In your Etsy host, it's just Razor. Okay.
That's the wrong machine now, isn't it? They're both the same. I could have just kept Razor, but.
So it's just in that alias that distinguishes the port, basically.
The difference is that the port is different, right? So when I say Razor, that alias is to SSH Razor 2011, and then I say Blade, which is no different because they're both the same thing in my Etsy hosts, but port 2015. Okay, so any questions about that? This is...
What's the password that we're supposed to use? Because it doesn't have our SSH keys on it.
Right. So that's what I have to set up because things aren't working right now.
Sorry, jumped again.
I'll do it by tonight. I can get you on the machine, but in order to be able to submit homework, I'll show you right now. So here's Blade. I'm on the box. First question is, since port 80 is open, how am I going to point my web server at Blade? Okay, and I think someone before mentioned the obvious way to do this, and that is SSH tunnel, port forwarding through SSH. So let's do that. So I'm going to SSH to Blade. Yeah, let me do it. -S. Open a port on my Macintosh, on my laptop. 8088, let's say. I don't know, some high port. Colon what?
Localhost.
Do you need a space in there?
I don't want any spaces. This is.
After L?
Oh, it doesn't. You don't need it. You can use it and you can not have it or whatever. Up to you. So what does this mean? This means open on my Macintosh the local port 8088, and then on the other end of the SSH connection I'm making, which is going to be to Blade, forward the same box. I mean, if Blade could see other machines, I could open a port on another machine that Blade can see, but I'm just going to open it on Blade itself. Its port 80 is going to be forwarded through the tunnel to my local port 8088 on my Mac. And this is going to be tunneled through my SSH connection via port 22. So I don't need to port forward or have this port available correctly. It's going to be hidden within my SSH connection. And I'm also going to have an SSH connection. I'm also going to have a shell. So where does my shell go through? Port 22 as well. So they're multiplexing this connection through port 22. I'm getting, some of it's going to be my interactive shell session. Some of it's going to be hiding this port 80 through the same tunnel to local port 8088 at the same time. So I'm using this tunnel in two ways at the same time, right? Okay, what do I type here? And? I need to say this port, right? Because Blade is just an Etsy hosts alias to some gateway machine. And port 2015 is port forwarded to Blade's port 22. Okay, so this should work. All right, and I should now have a port open on my local machine 8088. It's connected to Blade's port 8. So let's go try that. What do I do?
Localhost. And then 808.
Okay. So this is Apache 2, the default page. I didn't install a web page or anything. That's not, of course, the interesting thing for homework. That's just, I didn't put an actual web page up for Blade. The challenges are in, let's see if I can actually remember this. There's level 1. Actually, did I remember to fully post the homework? I don't think I did. Let me go do that. So today is the 14th, and I made it due on the 3rd, I think. I'm actually not going to be here that day. I have a deposition. Let's see if that works. No permissions. Okay, so homework due December 3rd, 2019. That's a Tuesday, so we don't have fully 2 weeks because today's Thursday. And so this is not 2 weeks, but it's 12 days. And I'm ignoring fall break because we don't exist on fall break, right? I don't want to give you homework over fall break because it's supposed to be a break. And then the last homework will be from December 3rd, due on the final. Right on time of the final, which is Saturday the 14th. So Blade's only 10 levels, not 15. Do the first 5. And you have an account on Blade, so go log in. That's not true, but it will be by the end of the day. The challenges are on HTTP Blade, twiddle level number, where number is 01 through 10. So it's not really this URL because you're going to have to replace this with localhost : whatever the local port is that you created via that same kind of SSH command that I just showed you. You follow? Okay. What does this twiddle mean? It is a relative path. I mean, yeah, it is a relative path.
The home directory.
The home directory of a user on the machine. Okay, so. Sometimes if you have a web server and you've got a bunch of user accounts on that Unix machine, the notation can be notated twiddle username. And this is analogous to how you say cd twiddle jr black to go to my home directory. Twiddle jr black expands to /home/user/jr black, or whatever the path is to me. And if you put twiddle by itself in bash, that means your home directory. And we learned before that if you change the environment variable called capital HOME, that actually changes the value of twiddle, right? For this to work, user_dir has to be an installed module in Apache. I'll show you that a little later today. But basically, this is shorthand for that user's home directory. And just like our web page here has a twiddle jr black in it, that just says, go to my home directory. And then go to my public_HTML. Have you seen this before? Okay. And then this is the subdirectory where our class web page is. So when I say twiddle level 1, here, it's going to the home directory of the user named level 1. So level 01 is a user on Blade. And so is 02 up through 10. Okay. And this is the challenge. It says user, password, and verify. What the heck are you supposed to do? I don't know. Go figure it out. Right? Look at the source for the web page. Is there some JavaScript running there? You can try and poke around in source code. Where's the source code? Right there. Yes, right?
Hopefully.
Whoops. Looks like that's the source code for this page we just saw. Looks like maybe there's some JavaScript going on. I don't know. We can go into this. Oh, I can't see that. So, right, so parts of this are going to be available to you to look at. Parts of it won't be. See what you can see, figure it out. You may have to do some poking around, but the goal is to get some magic string, and that's the answer for the level. Well, that and an explanation of what you did is the answer for the level. So when you are ready, there's another user on the machine called submission. And submission is where you, submit your stuff, okay? So every time you have an answer to a particular level, go to twiddle submission. I think, is this in the instructions?
No. It's to submit your solutions at late.
Oh, yeah. Okay, so, yeah. So you go to this user's homepage, the submission user, and you click on the appropriate link for the level you solved. And here you're going to have to put in your perm number, which is the thing that I was trying to collect from each group. Group meaning group of you, pairs of people or singletons if you're working alone. You need a permission number, which is an 8-digit random number that should not be guessable. Because if it's guessable, then some malicious entity known as your other friend could come in here and submit false solutions under your name. Right? So your permission number is kind of like, it's not really a password, but it's like a number that keeps it from being trivial for other people to submit work under your name. So I need to establish that, and if I can get that working by tonight, we'll do that. This only, if you don't have a perm number, it means you can't submit. It doesn't mean you can't start working on the homework. You do need an account to start working, which is the top priority. I'll get an account set up by tonight. If you solve a level, you can just make a note of what the solution is and then move on until the perm number stuff gets set up, and then you can submit. Unlike Razor, you don't have to do these in order. So it's not like you can't see level 2 until you do level 1. You can do them in any order you want. Once you have a perm number, you enter it here along with your username. And the password, that's not the password to your username. Password is the answer to the level. And so if I go look at level 2, it's not going to ask for a password. Here it wants the perm number and the file contents. So level 1, the answer was username and password. This is file contents. So go figure out for level 2 what something called file contents should be there. Let's see. This takes a minute. So there's some file apparently that's interesting, and you want to find its contents and post that to submission. Oops. For level 6, I don't know, contents. Find the contents of the S3CR37.password file. It's contents. In each case, you want to enter in the description what you did. This doesn't have to be a 7-page essay of what you did, but I think you know what kind of level of detail is appropriate. I injected this to get the program to divulge that, and then I did that, and a couple paragraphs in text. There is no printed hand-in for Blade. You just submit it here, and Nick will review what you did via the typed-in description for each of your groups, your homework groups. So you don't have to print anything out and hand it in for the rest of the class. Yeah?
If you resubmit,
it will overwrite. You can update. So you can submit as many times as you want until the cutoff date, which is December 3rd for the first 5 levels, at which point Nick will then read what you wrote, and if you update it past that, we won't ever see it. Because we're not going to look at it anymore.
Will it tell you if you get the wrong answer? Wrong contents or something?
Gosh. Yeah. That is the answer, I think. Yeah. I could go look right now, but I'd have to look at the source code for the Python that checks the answers, and then all the answers will be on screen. But I think it checks. It's not going to check your description. That's going to be human, right? But the actual solution, I think, is checked. Are you thinking, like, maybe I'll just brute force this?
No, I guess I'm just saying on, like, the first levels, I mean, it's nice when you're, like, you would get a response of, like, what are you doing, man, or something.
Oh,
you
yeah.
knew you didn't pass, and you had to keep working, right?
Yeah. Yeah, it would suck if you thought you had the answer and you typed it in and it turns out it wasn't right. I think it does check. Gosh, I wrote this. You'd think I'd know the answer. It's been a long time since I last looked. Also, there's some ranking page. I think it's standings or something. Where is it? Was it on the homework?
If you go back to level 2, you can probably find it.
Okay. Oh, also, contrary to the other challenges, this one, you can abuse the environment once you break in. So there are vulnerabilities in some of these web pages that let you blow up the web page, which means no one else can then do their homework. So I'm asking you not to do that. Or if you inadvertently screw something up, can you let me know so I can restore it? Because I want everyone to have a fair shot at being able to do this without having to wait a day for things to get corrected, because it'll slow down the whole class. Some of these are read-only attacks, but other ones you can actually pretty severely mess up the page. And also, if you're solving and you stumble upon the answer trivially because someone else left it lying out in the open, please don't just submit the answer and go description, well, it was just sitting there. I want you to break the thing. You'll know when you're like breaking it versus just stumbling onto the answer. There's one level where you inject JavaScript, which then steals the cookie or whatever and then writes it to /temp. So if you're in another group and you're like, oh, I found the answer sitting in /temp, that's not a break of the page. You have to go write the same malicious JavaScript that does it. You can't just find someone else's answer. Ideally, I'd give everybody a separate machine. We just don't have the resources to do that. All right. Gosh, what's the... I'm trying to remember what the name of the account is for standings.
Score.
Score sounds right. How did you know that? Because it was the name under Razor? Let me go find it. Do you see anything that looks like a ranking or score or a status that's not a name of a user? It could also not be it could be a non-twiddle name too. Which would be under.
So maybe if their username Rainwater last week?
Brian Rainwater. Anybody?
No.
Rainwater sounds like meningitis or something. Should be nice. He's not here. He's a good student. Now I am obsessed with this. Let's see. Doesn't look like it's a user account, right? Oh, I think under submissions, it might have had a link to it. Scores. So it's under, it's a sub-part of submissions. Okay, so if you're concerned with making sure you actually got credit or keeping up with the Joneses, here are the levels. There are 10 of them. So your username will be down the left side, and X means you got it. Looks like 9 was hard, huh? Yeah, 9 is hard. In fact, by far the hardest level.
That's good to know.
Yeah. Is Nick here? Yeah, here he is. Oh, he did get 9. Uh-oh. Yeah, very few people got it.
So we can have a challenge answering our questions.
Yeah, right? We'll have to make sure he knows how to spell 9. But that's after the break. Unless you're one of those overachievers who wants to do all 10 levels by tomorrow or something. All right. So that's the drill on Blade. Any questions about, you know how to do the port forward? And as soon as I get you an account, you obviously know how to log in. It's the same as Razor. And you can start cracking tonight.
Would it be possible to just copy the .ssh file folders for everyone so we already have the...
Would you want me to do that?
If you could, it would make it a lot easier just to log in right away.
Yeah. All right. So I'll do the work and you... Wait, I just agreed to that?
Yeah, you did.
Okay. I was just going to make passwords look like last time. Anything else for Blade? Okay. Quiz, week from today. Did you see my Slack message? So it will cover everything in the course up to the end of Razor, but I'm not going to ask you about like netcat options or something like that was from, but I could ask you something about Simlink mazes. Remember those? It seems like ancient history now, but that's part of Razor. I could ask you anything about bash. I can ask you obviously about up buffer overflows, off by one errors, canaries, format string, vulnerabilities, all that stuff from 1 to 15 on Razor. That's what the quiz will almost entirely focus on. And I'm going to give you the full class period this time, because last time I gave you half an hour and then people were here 45 minutes in. This one's harder because it's obviously more intricate details with Razor. I'll give you time to think. Some of you may be gone 30 minutes, that's fine. And then you can go take your break after that. Okay? Any questions on that?
With the quizzes, are they going to be, because especially on the last quiz, the average is pretty low. Are they going to be curved at all?
Yeah, absolutely.
Okay.
Yeah, so the way I do it is, I can't remember what the quizzes are. They're like 20% of your grade or something like that, and there are going to be 4 of them in total. So each one will be 5%. So I'll just weight them, and I'm going to weight the first one a little less, as I promised. It was a prereq quiz. And then that'll be 20%, and then most of your grade is the homework. It's all of these leveling exercises. And then the final will also be, I can't remember what all the weightings are, but I put it in the syllabus. And then you'll come up with like, I don't know, 72% out of 100. And maybe the highest in the class is 83% or something like that. In which case, I'll get a curve. It usually looks like a bell curve with 17 people. Maybe it won't be perfect because that's a small number of people. And then I'll just draw the A's down to, I don't know, the top third of the class, or maybe the half of the class, or something like that. But I won't say you have to have 90% to get an A, because that may not happen. So people are usually pretty happy with the grades they get in this class. I don't want to say that like, you promised me I'd be happy. No, I'm not happy. Yeah.
The extra credit for the homework, does it add to the homework grade or the total grade?
The total grade. So usually on the extra credit, if especially if you're on the border between 2 grades, it'll help push you over the edge. But I look at it as a separate category. It's not factored into your. There's no category for extra credit among your grades. So really, do not fixate on extra credit as a way like, oh, I'm worried about level 12. I can't do it, so I'm going to go do the extra credit. The extra credit's harder than level 12 and counts for less. Do the homework first. Anything else? All right. Like I said before, this stuff is easier but harder. It depends on how your brain works, right? If you're really good at a very well-defined, bordered-off problem that you can focus on, then you're going to be better at Razor. And if you're better at Linux and binary exploits, you're going to be better at Razor. This has fuzzy edges to it because there's this massive HTML, CSS, JavaScript, PHP, all this stuff all over the place. And it could be, the vulnerability could be anywhere. Usually in Razor you could find the vulnerability really quick, but the exploit was hard. Here, the vulnerability is anywhere. It's hard to find it. Once you find it, exploiting it except for maybe level 9. It's pretty easy. I shouldn't say easy, it's pretty straightforward. But a lot of people come to me and go like, I don't even know where to start. What the heck, you know, I see all the code, I have no idea what to do. And if that's the problem, then come to me and say that, and I'll try to push you in the right direction, or Nick will. Okay? Don't get discouraged. This stuff is in many ways more applicable these days than like most exploits that you see actually in the wild, like taking advantage of credit cards are missing, 10 million user accounts are stolen. More like this stuff. Cross-site scripting, cross-site request forgery, SQL injections, and things like that. Okay. Good? Let's go back to what we were talking about. I am more or less just right now doing what I hope is mostly a review. It might not be. Some of the details might be new to you, but I hope you've seen this before or you vaguely know how this stuff works. So last time we were talking about clients and servers. The client is a browser or a browser simulator, a fake browser, headless browser. Server is going to be a web server. Often it's Apache. Apache has the biggest market share in the world. It's a huge production quality, open source, teetering pile of code written in C. It's on 2.4. Some people are migrating more to Nginx or light HTTPD. And some people are IIS all the way, which I've never even used as an admin. We looked at the format of client-server interactions via HTTP 1.1. We had in text a request as the first line, all headers, blank line, and then a body, which is optional. The response comes back in a three-digit number, 100, 200, 300, 400, 500 families. Blank, any headers come back. What header might a server send back? Set cookie. Right? That's one thing servers do. Blank line, and then a body. Servers very commonly send back a body because servers send back resources like GIFs and things like this, right? Okay. And then there's a keep alive of a particular number of seconds that's configurable. The server decides how long to keep the connection open. 5 seconds, 10 seconds. Google will keep your GWS, the Google Web Server, sometimes will keep your connection open for up to a minute because they've got a lot of resources, so they can hold open a connection for a minute without killing them. All right, so how does the client send data? So the client can send no data, no body, right? It just sends, I want the root document, which is get space slash space HTTP 1.1. Slash means give me the root document. And then there's no body. But sometimes clients want to send data. And the typical way is with form data. What do I mean form data?
Responses to forms. So
what's a form?
It's like some place to fill in data on a web page.
Okay, so you've seen a million of these, right? A form is a web page that has pull downs, radio buttons, text boxes that you fill in. You, the user, submit information. Once you hit a button, usually called submit or something like that, all those data that you've inputted are packaged up and sent to the server. Now usually we think of the server sending the data to the client, but in this case the client sends data to the server. How does it do that? There are two main ways. There's get and post. Is this familiar already? So with get, the parameters, all of the stuff that you, the user, typed in and clicked on and so forth, are encoded into the URL itself. And so when you submit the request, the get request, to the server, part of that get is actually going to have all of those data encoded into the URL as what are called get parameters. Have you seen this before? Yes. Okay. The other way is to do it with post. In the case of post, you don't see in the URL all of the information being sent to the server. That's actually in the body. So it's after the headers, blank line, and then the body. And that's where all of those data are sent. Those are two distinct ways of doing it. let's look at examples of each. So, I think I have it on Razor. Oh, does that mean I have to forward on Razor? Yeah, I think I have it on Razor. Let me go check. So Razor still has a use. What did I just call it? 8080? All right, so here is I just forwarded Razor's port 80 to my 8080 so I could talk to Razor's web page, web server. I don't have any other way to do it, right? It's the same thing you're gonna do for Blade. And there's nothing interesting on Razor as far as homework and things for you to attack. I just have it there for a bunch of demos. All right, so here's a form. If I look at the source code for this form, it says this. So HTML, here's the start and end of the form, here to here. There are two text boxes. One's called name, one's called email. Show me your hands. How many people have done this before? About half the class. Okay. So form is just an HTML object, and you can put in pull-down lists and radio buttons and menu selections and text boxes. And text boxes are the things you actually type in the answers to. This is the name of the field, the name and the email are the names of the two fields. The user is going to fill these in, and then she's going to click on this submit button, and that's going to cause an action to occur. And the action here is to go to another web page called welcome under get.php. And the method, which is exactly the topic that we're talking about right now, this could be get or post. In this case, it's get, and that means that the answers here are going to be encoded into the URL when we go to this next web page called get.php. All right? So if I do that, you'll see, I click on this, it goes to another web page called welcome under get.php, and the answers that I entered in the form were name and email. Name equals J plus R plus black. So what happens is the name of the field was name, and it's a key value pair. So it's the name of the field, an equal sign, and then the answer where my answer spaces are replaced by pluses. This is just the basic URL encoding method. And the way that we separate the name of the page from the parameters is there's a question mark. Indicates these are get parameters. And then it's key equals value, key equals value, key equals value with ampersands in between. So here were there only one, so there's one ampersand. The @ sign had to be URL encoded, so it's %40, which is the ASCII for an @ sign. You seen this before? Okay. What's good about this? What's bad about this? The idea that what I just typed is now displayed in my URL bar in this get parameter format.
Public.
So it's shoulder surfable. If maybe a password I typed in got displayed here, maybe that would suck because somebody walks by and sees my password sitting in the URL bar. Maybe it'd be better if it were hidden. We're going to do it a different way in just a second. Let's do it now. So if I instead go to another page called welcome post, it looks exactly the same, right? But notice, it still says welcome JR Black, your email address. It just echoes it back. But notice now, in the post case, you don't see those parameters in the URL bar, right? Where are they? They're in the body. They were in the body, and the body is not displayed in your face when you click on go to that web page.
Is that, you said like that URL is shoulder surfable, but is it also sort of like sniffable? Doesn't something have to go to a,
yeah,
like it's not, it wouldn't be encrypted.
This is not HTTPS at all. So if some man in the middle,
yeah, or
even some passive sniffer, were watching my transaction, and there's a password, let's say, going by instead of just my email, you can grab it out of the URL, because the URL is going to be in the body of the TCP, right? It's not going to be encrypted because it's not HTTPS. So you're going to see get space / welcome under get.php question mark, and then all the parameters will be there. But in post, if you sniff it, it won't be there in the URL, but there's going to be header, blank line, and then it'll be there in the body, so it's sniffable either way. So you're not getting any any resistance to someone sniffing your connection. That's going to give up all the information in either case. But in the case of get parameters, it's viewable right in your browser, right here. Everything you typed, everything you filled in is going to be viewable.
Is there a difference if it was HTTPS?
In HTTPS, then it would still be here and visible to any shoulder surfing, but it wouldn't be visible if somebody sniffs the connection. It'll be encrypted. And then in the case of post, it won't be there, and it also won't be available to sniffing because it's encrypted. So in the HTTPS case, it's better to use post if you're worried about shoulder surfers. Now that said, passwords shouldn't be passed as get parameters. That's a bad website design. Because any web designer knows that get parameters are going to show up in the URL bar, and therefore any sensitive information shouldn't be there because people might walk by in a public setting. If you're in your home, maybe you don't care. If you're in a library, you care. By the way, don't ever go to a library and type in passwords, right? I mean, don't go read your Gmail from a library. Because?
Who knows what someone else has put on there?
That's right. Using public hardware, there might be a keylogger. It could be a hardware keylogger, it could be a software keylogger. It's fine to go read the weather and the news. Just don't type in your password to anything sensitive. Don't log into your bank account from an internet cafe. It's just asking for it. You can use your own hardware, your phone or your laptop, on an untrusted public Wi-Fi, but you have to know, like, there are things like spoofed Wi-Fi devices. You could be getting man in the middle. You have to be sensitive to that. Okay, that was a digression. Back to this. So these are two different ways to pass parameters. Any questions about that so far? So in this case, it's right there. Now, what is regurgitating my name and email address?
PHP.
Some PHP code. So there must be some PHP code in this welcome under get.php. There's also welcome under post.php that is receiving, in this case, the get parameters from the command line and somehow formulating a web page that regurgitates them back down here. And the same in the post case. It's somehow receiving them from the body, not from the URL, and regurgitating them on the screen. So let's go look at how that works real quick. We're not going to learn PHP just yet, but we will in like 10 minutes. So in the get case, who's ever written PHP or read PHP or seen PHP? Very few people. Well, fewer people.
There's no therapy over it, by the way.
My condolences. Is there any language that someone in here doesn't hate? Okay, every language has fans and haters. What?
Does everybody like Python?
Yes.
If you don't, then you're wrong.
Which Python?
Python 3, hands
Three.
down. If you are a fan of Python 2, you were wrong. It's being depreciated in a month.
I've got millions of lines of code of 2.7
Yeah.
that I still have to like look at. So, all right. Strong opinions from the left side of the room. All right, this is PHP, and yes, I am sorry to all of those who have to seek help after this class. All right, so the way PHP works is like this. So this is just HTML up to here. Yeah? And if that's all there was, then the web server would just serve this. The browser would look at it and go, it says the word welcome, put that on the browser screen. Now, when you see this tag, not you, when the web server sees this tag, the highlighted portion, angle bracket question mark PHP, it knows that it needs to pass this portion to a PHP interpreter. And how it does that, I'll get to later. It's either a module that's sucked into Apache, it's kind of built into the same address space and runs within Apache, or it's a separate outside process that gets forked that then interprets it as a CGI. But in any case, Apache sees that PHP tag and says, okay, that's for the PHP interpreter. PHP interpreter is invoked. This needs to be valid, syntactically valid PHP. PHP runs and says echo. What do you think that does? It's just like a print statement, right? Just like bash's echo. Echo this, and if this were just a constant string, it would just repeat it, and then we wouldn't even need PHP in that case because we could just put it over here in the raw. But it's not. It says $_ get. Get is what's called a super global, which we'll get to when we do PHP. And there's this array indexed by strings. And the index of the get array is the name of the variable that you're receiving. That makes sense?
This is like a dictionary?
It's like a dictionary in Python. Yeah, or associative array, if you prefer that term. And since the variables being passed in here are name equals some value and then email, those are the two values. In get, you can put either name or email, and you'll receive, what do you think? The value after the equal sign here. So you're going to get John R. Black in the first case and the email address in the second case as a value. So what PHP will do is it will replace everything from the opening angle bracket question mark PHP to the close question mark angle bracket here. That'll get removed by the server, well, by the PHP interpreter, and replaced with the output of that command. And in this case, it'll be John R. Black, and in this case, it'll be my email address. And this comes back, and Apache just sees welcome, my name, whatever my email address is, colon, and then sends that to the browser. And the browser, does the browser see this PHP code? No. So the server sees the tag, sends it to the PHP interpreter, PHP runs, replaces it with the output of the program, the PHP program. That's taken by Apache, sent over the wire. The browser has no idea that this ever existed, where it came from. As far as the browser is concerned, this is just a static page. If I go look at the source for this web page, the browser just sees the output of the PHP. That will affect you in your homework. You'd love to see the PHP. In some cases, you won't be able to. And you'll have to, you don't know what PHP was running in order to produce this output. That's on purpose, right? We don't want, from a security standpoint, we don't want the users to know what the underlying PHP code was, because there might be a vulnerability in it. You just get the output. Okay? Now, PHP is parsing the URL here, right? It's taking in this URL and it's creating a, would you call it dictionary?
Yeah.
That's the Python word, right? It's creating a dictionary with index being the part to the left of the equal and value being the part to the right of the equal. Same thing here. So what would you guess if I did this again and I took the A out of the word name?
You know where.
It just wouldn't replace anything.
It would still create a dictionary, but the key now would be NME, right? And then what would happen to the PHP code?
Just
Wouldn't show a name.
It would find no value here, right? So it wouldn't show the name. Will it blow up? I think probably not. It'll probably just be blank. So let's try it.
If you hit refresh, it just.
You just need to hit enter instead. Okay, so there's no name. These, of course, the code won't see it if it's off.
What was that distinction? Why does refresh? It doesn't. Seem...
Oh, refresh is going to actually pull up the last URL and stick it back in the URL bar, which had the correctly spelled N-A-M-E.
Oh, yeah.
But I need to edit it and then hit enter, and then it'll stay. It'll stay in its changed form. Okay. Yeah.
What will happen if you have a semicolon in the URL?
Semicolon in where?
In the name.
In the name?
Yeah.
Like there?
Yeah.
I don't know. Let's see. It looks like it's faithfully kept.
What happens if you put an and in the name?
That's gonna mess
that
up
needs to
the
be
sync.
escaped.
Yeah.
Yeah. That'll mess everything up.
Okay, you have to type it as ASCII then, as an ASCII.
Yeah, I'd have to put it in as an ASCII encoded, like, I don't know what the percent is. Something. Turns out that's just the number 3 that I typed in. Because 33 hex. This is hex, by the way. Okay? For post, in the case of post, it's actually not much different from the PHP side. So that looks the same. And if we go look at the PHP, what's different here? Yeah, it's just saying receive name and email this time as post parameters instead of get. So PHP will not try to parse the URL to find these 2 key value pairs to fill in this dictionary. It'll instead look to the body. Okay, where's the body? If I look at the source code here, will I see it? Why not?
It's like what you said.
Before the HTML was created.
Post so it gets passed to the server, but the server doesn't pass it back to the client then.
Right. So this is what's coming from the server back to the client. This is after PHP is run. Post is formulated from the client to the server. That's where the body contains. If I wanted to see the post parameters, right? They're not here. They're not up here like they would be with get. Where can I see them? I know what they're going to say, but
Chrome Inspect Network Tab.
say again.
Chrome Inspect Network Tab.
Chrome Inspect.
Yeah.
Really?
Yeah.
And then do it again and watch it go?
Yeah.
Okay. Okay, so this works. I was going to do it a different way. What we'll do later is we'll use a burp proxy, I sort of mentioned, which is a Java program called burp that you have as part of Kali, as part of Kali. I've got it actually on my Mac as well. And you purposely direct your browser at burp, and it will intercept and let you change things. It'll intercept and freeze the connection and let you edit stuff before you then forward it to the server. And the response will come back, and if you want to, you can capture that and edit it before it goes back to the browser. Is it? So this is the form data that was just submitted. I wanted to see it raw. Is there a way to see it raw instead of formatted?
View source.
No, that'll, I think, view the source of what's come back. All right. Well, these are the request headers. So what happened was on the request, which is from the client to the browser, these are all the headers. That cookie is still being submitted. There's the host header. That's the only mandatory header. And then there was a blank line, which I can't show you because it's formatted away. And then the form data after the blank line, this is from the client to the server, it submitted this. View source, that'll show it to me. This is how it actually submitted it. So this was textually in the body of the request, and it would have said post up top instead of get. There's all the headers, blank line, and then this single line. And this is what PHP is parsing in order to fill in that dictionary that has name and email. Okay, any questions? I also wanted to go look at this list of trade-offs. Somebody said shoulder surfing was a problem. Will it go to Chrome?
It's an ASP file.
It's active server pages, which is the Microsoft version of a JSP. It's for the .NET stack. If you see ASP, you're talking to Microsoft shop.
Or ASPX as well.
Okay, so here are some trade-offs between get and post. You can hit the back button or hit reload. Get, it's harmless because the parameters are on the command line. And post, have you ever hit a reload and it pops up and it says your form data is going to be resubmitted? Are you sure you want to do this? That's because your parameters are via post. Bookmarks. How would bookmarks vary? What's a bookmark? You just tell your browser, I want to remember this, and it just saves the URL, right? Into some file that you can look up later. So what happens if you bookmark something with get parameters? If you go back via the bookmark, you'll submit the same form response again. All the same parameters will be submitted because they're in the URL, right? But if you do that with post, it's just going to keep the URL for the form submission but not have the actual data that you filled in. So change things with bookmarks. History, the parameters remain in the browser history and the get. Get is less secure because if there's sensitive data, like passwords, they'll be saved in the bookmark or they'll be viewable in the browser bar. And post is a little safer that way. All right, so I think...
What is multi-part encoding of that? Encoding type?
I don't know offhand what they're talking about there. I thought it was chunk encoding, but it seems to be not. I don't know.
Can I ask, I hope this isn't a silly question because it's sort of related to my old question. You bookmark something with Git and you go back to a page, HTTPS. That's going to be sent unencrypted, right? Initially, as part of your host thing? Or is that not true?
Well, if the bookmark has HTTPS in it,
isn't it going to have to go try to find this website and send that? Wasn't that what we were talking about the other day, like the SNI? Like it's going to have to send that unencrypted, right, to find the...
SNI will just be the name of the server, though. It won't be the full URL.
Okay, so maybe that other stuff won't get sent that way. Okay.
I mean, if you go to, let's say, an unencrypted, you go to port 80, it's not encrypted, you get redirected to 443, you'll now have HTTPS in the URL bar because you're going to speak SSL. You do the SSL handshake. You then submit a form, and it's using GET parameters. So it's in the URL bar. And you decide to bookmark that. You'll bookmark the HTTPS as well.
Mm-hmm.
Now let's say tomorrow you open a tab and you click on that same bookmark. The browser is going to see HTTPS. It's not going to go to port 80 and be redirected. It's going to see the S and it's going to say, go to this, go do a DNS lookup, and then go to port 443 of the IP address and do an SSL handshake, and then submit that entire URL with the GET parameters and all that. That will be encrypted now because you've done the SSL handshake.
And the DNS lookup, though, only will be for that first part of
the DNS lookup is only going to be the blah, blah, blah.com or whatever domain name. Yeah, and it won't include the URL parameters. Nor will the SNI have it. Because SNI is also in the clear. Okay. Anything else?
So the multi-part encoding is if you want to send a file as part of your form. Because then you can send binary data instead of just ASCII.
Right. So, but what's the distinction here between GET and POST?
With GET, you can't send a file as part of a GET request. With a POST request, you can send a file.
Okay.
So you can use the multi-part encoding to send not just text, but also whatever, a PDF or something.
It's weird because it has that other row that just says restrictions on data type below. That sort of seems to say that same thing, though.
Yeah, so you can send up to 2048 characters, right? You can't send 10 megabytes in your URL.
Or I guess one below that is just saying POST has no restrictions. You could send binary data.
Right, this is ASCII only.
Yeah. So I don't.
Yeah, if you're ever like uploading your resume to a job site or something, that's not going to be a GET parameter. It's going to be POST, and it may even be multi-part, which means that it's going to send in different chunks.
Like if you do form URL encoded, that's using that like and something question mark something format. So you can't send binary data if you're using that encoding. So the only way to send a file would be to then be able to send binary data.
Can't you send binary in as a GET parameter by using the ASCII encoding though?
In theory,
Thought you could.
You're very limited on file size.
Yeah. I don't think you could send a file that way. Files are sent via POST, in my experience. Okay, so let's move on.
So theoretically, you can send shellcode in GET because that's only 40 bytes.
Yeah, you can send shellcode that way. There is some shellcode in one level of Blade, so be aware. It's obvious when you see it. Okay. Cookies, notorious, been around since the 90s. What's a cookie? Just tell me.
A bit of data that a website will save to your machine that it can then access again to get information back about you.
So cookies are a short string key equals value pair, semicolon key equals value pair, can be a bunch of different key equal value pairs sent by the server to your browser saying, will you please hold this for me? And every time you talk to me from now on, always give it back so I can recognize who you are. Now, it's up to you, the browser, to be faithful to that. You don't have to accept cookies. And you don't have to send back the unchanged, unaltered version of that cookie. In fact, like I said last time, it used to be that Amazon would store whatever your discount rate is in a cookie, and then people could just change it to a higher discount rate. And that used to work. Okay, so what happens is the server sends it in the following form. It has a header, which means it's the part that occurs before the blank line. It says set cookie, name equals value, separated by semicolons. Cookies can also have expiration dates, and it's this format. Here, expires equals, so expires is a special key value, and you give it a date and a time, and that means that after that date, you don't have to send that cookie back anymore. If there is no expiration date, then it means until the browser terminates, until the tab is closed on your browser, end of session. There are other special keys as well, like HTTP only or secure cookies and things like that. We'll talk about when we talk about XSS, cross-site scripting. The browser is supposed to send back the cookie every time unaltered, and the browser looks up in its cookie storage, which is called a cookie what? Jar. It is. It's called the cookie jar. It's where you keep your cookies. It looks in the cookie jar, indexed by domain. So if I go to google.com, I go down the cookie jar and I find google.com and I go, okay, these are the cookies I send when I go here. But I don't send the facebook.com cookies to Google and vice versa, right? So they're per domain. Why would a server ever set a cookie? Okay, authentication. What else?
Save your login.
Save your login. So it's because HTTP is not persistent, right? If you log into Amazon and you surf for shower curtains and books and electronics, it doesn't keep that TCP IP connection alive the entire hour that you're online, right? The TCP connection could be terminated. But you want this experience where you log in and then you don't have to keep logging in every single time there's a TCP connection going on, every 12 seconds or something. So it needs a way to remember who you are. Now, one way to do this is your IP address, but as we've said, everyone in this room shares the same IP address. So how does Amazon distinguish between you and me? Also, IP addresses change because you can, you might log in from home, from work, from Starbucks, from school. So what happens is when you log into Amazon over at HTTPS, you submit your name and your password. Those are sent encrypted because it's HTTPS over to Amazon, who then hashes your password, looks it up in a database, matches the hash to the hash password and your account name, says you're logged in, sets a cookie in your browser that has some unguessable string. Now you, every time your browser responds to Amazon, even if the TCP connection is terminated, sends that cookie back. It looks it up. It looks up the cookie in a list of active sessions, finds your session, and reestablishes context. It says, okay, Alex is already authenticated, and he's on this page, and he's got this shopping cart, and so forth. So it keeps track of sessions. That's one thing we can do anyway.
In that situation, like, how do you? Because it would be like, I guess, relatively trivial to if you had access to their machine, say, to copy that cookie.
You hijack their session.
So there's no check for like any unique identifier.
That it's supposed to be a unique identifier.
I mean, like to their machine, say, like if you copy it to another machine, that it doesn't work, or
yeah, I mean, but what would you do?
MAC address or something.
I feel like they usually correspond. I mean, at least with IP. Like if you try to go to another place, I mean, usually cookies won't get you in if you go to a different IP address. Like, I mean,
yeah, I don't know. I don't know what happened if I logged into Amazon and got a cookie for my session, and then put it on the board and had you guys hijack my session with that cookie. If it would notice that your MAC address had changed, or if you did it from a different IP address, it would notice that your IP address has changed.
It definitely notices IP addresses have changed.
Actually, if we're all doing it from this room, the IP address wouldn't change.
That's true.
I mean, it wouldn't solve that problem, but like if you do that and then you go to some IP address that it hasn't stored, it'll be like, we've noticed you're logging in from like a new computer or something. Like, please re-enter your credentials. Like, it's super common.
Doesn't that destroy the purpose of cookies? If it has to check his IP address and the cookie, might as well just check the IP address.
It's just sort of like two-factor. Like,
Maybe.
if now you're like logging in from some IP address that has no record of you ever logging in from, it'll ask you to re-enter your password.
Yeah, but it's
like
still
that.
bad setup because, again, all the private IP addresses map to one public IP address, and that one public IP address is all the Amazon sees. So,
I mean, it's not foolproof, but
is there a scenario
there's a Barbados IP address.
Is there a scenario where you could be logged into Amazon, let's say, and your IP address might change during the session?
Yeah.
Through a VPN?
Or even, this might be different, but through like cell phone applications, right?
Like being relayed through different cells, your IP address could change?
Possibly.
Or you just go to Wi-Fi.
Yeah. From cell phone. Cell phone network to Wi-Fi. Change that.
Yeah, because you're going to get a new IP address. And should your session stay alive if that happens?
Yeah.
But like a lot of websites are definitely going to kick you off and make you re-enter.
Make you re-authenticate?
Well, the confusing part is that my browser saves my username and password, so I'm not sure how often it's having to, like, doesn't it, yeah, I guess I'm not aware of.
But even when your browser saves your username and password, doesn't it at least show you that you're logging in again and make you click the login button?
It does.
That's happen with Gmail exclusively. With Gmail on some websites, you just click on them and you're through. Yeah. Especially email websites, Outlook, Gmail, all of them, they don't ask you to re-click. Like, they don't have everything typed in and then you just click and you're going in. It just opens up the inbox.
That's right.
Is that with a password or is that with the cookie?
Yeah, exactly. What is doing it? Is it your saved username and password that's giving you the authentication, or a cookie which has been set by Google ages ago?
I think it's the former. I'd have to go investigate, but yeah.
Is there more? So I don't think that the IP makes much sense, but
tracking IP.
Yeah, but is there like session information that would make it hard to like? Would you need more than just the cookie? Like all of a sudden there was.
I mean, it does look at your MAC address, right? Because sometimes you'll get a notice that says, we're noticing this is the first time you've logged in from this computer. It's either based on MAC address or...
Well, shouldn't the MAC address be logged on? Because once you hit the first router, that Ethernet header is...
No, it's JavaScript that's running on your device. It's looking at your MAC address and saying, we've never seen this device. You've never logged in from this device before.
Okay.
So the JavaScript's pulling your MAC address and sending it to the server, which is then putting it in your account saying, these are your devices.
I see. Yeah.
That makes a lot of sense. So I think it's a MAC address versus session. That makes sense.
Yeah.
You can put your MAC addresses in your Google account for which devices are authorized. Like you can just go straight look at those MAC addresses.
You can go into the Google database and say which devices are authorized for this.
In the security settings part of your Google account, like you can look at like authorized devices, and under each device they list what MAC address it is.
And that makes sense. And you can remove devices too, right? Mm-hmm. In case you sell something. I mean, I don't know who'd be that diligent to go and say, I sold my iPad, I'm going to take it out of all my accounts. But that would be the smart thing to do.
Good to do once a year.
Okay. So cookies are used for session management. That's maybe the primary use for them. They're also used for tracking you. This is why all this privacy stuff happened with the European Union and so forth. What happens there is that you go to a website X and you're searching for pickup trucks or something. So what happens is the ads. So there are these big ad companies, right, like DoubleClick, that serve up ads. And the way that happens is you go to some website that's social media or something like this. Social media makes its money by serving up ads, but they don't serve the ads themselves. They allow another company to embed in iframes, in little miniature windows within your window. They sell the space to advertising companies. And those ads are served up by a different doubleclick.com domain. Now, doubleclick.com is going to set a cookie in your browser that is wed to DoubleClick, right? Because cookies are tied to domains. They're not tied to whatever you typed in. They're tied to whoever served up that content. So if there's a little iframe in the corner that's served up by DoubleClick, you're going to get a cookie that's owned by DoubleClick that says, every time you go to DoubleClick, give me this back again. So then you go to Facebook, and Facebook is a completely different website than you were just on. But it also sells advertising. That's how it makes money. And it sends you to DoubleClick again, and your browser goes, oh, I'm going to DoubleClick. Here's the cookie you asked me to send back. And DoubleClick goes, oh, you were just looking at pickup trucks, so it gives you more pickup trucks. And you go, that's creepy. How did you know I was just looking at pickup trucks? It's tracking you via cookies. Okay, cookies have been controversial since their introduction because of this kind of like weird, creepy privacy stuff that happens. There have been pushes to get rid of them. Of course, there's a lot of advertising dollars that want to keep them alive. They're also used for storing information long term. Sometimes a server wants to store information on your browser. They're limited in this way because they can only hold 4,096 bytes for each domain, which is maybe less than what you want for some applications. So in HTML5, there's actually a different kind of storage called web storage. There's there's session storage, and there's local storage. And so this provides a way for JavaScript, which is running on your browser, to store stuff within your browser's memory up to 5 megabytes per domain. And there's no network traffic. So it doesn't have to, with cookies there's network traffic, right? Because the server sets the cookie that sends it across the network, and then every single time your browser communicates with that server, it sends it back, even if the server doesn't even want it right now. If you got a bunch of information stored in the browser, it sends it back every single time it talks to the server. Here, it's only accessed by the JavaScript that's running on your browser, and it's used basically locally by the JavaScript, and up to 5 megabytes of information stored locally. When would you ever want to do that?
You're running like a larger web app that you don't want to have to re-download.
It's 10:45. Have you ever played this game?
Too much.
Too much?
Too much.
Yeah, so, I mean, if I'm right here, and then I quit and I go back to it again, it remembers where I was. The game store. Oh, look at my high score. the game stores wherever you last were in HTML5 local storage. And the cool thing is, you can go and edit that. You can edit the current board. If you want to impress your friends that you got like 4096 or 8192 as a high score, it's not that hard to do. Just go edit this. Or if you want a really good best score, you can go edit it directly. But it's not a cookie. First thing you might think is, oh, that's in a cookie. It's in local storage. Okay, sorry I went over. Have a good weekend. See you next week.